The fifth lesson in Module 4 is on arithmetic sequences. Now, this is a very interesting lesson. Let's jump to the learning objectives. They are to construct arithmetic sequences and to apply the arithmetic sequence formula. There are a few keywords. They are sequence, term of sequence, arithmetic sequence, common difference, and term of arithmetic function. We will learn all of these when we solve problems and when we learn about arithmetic sequences. So we will now see what exactly is arithmetic sequences. Before we start, I'll write some numbers. Say over here, -4, 1, 5. Sorry. Let me do this. I don't want to make it very, very obvious so that you easily understand. Okay, now it's 5, 9. With these numbers, can you see any pattern? But if I start writing more and more numbers, you might see a pattern that emerges. What's happening here? If you look carefully, you can see 5, 9, 13, everything has a difference of 4. I've added 4. 1 plus 4 is 5. 9, again 4. 13, again 4. 17, again 4. 21. And over here, if I subtract 4 from 1, it will be -3. You can see the difference between these terms are all 4. And you can see the difference is common or the same difference everywhere. So this is an arithmetic sequence. If you have a sequence with a particular pattern which is same throughout, that's called arithmetic sequences. Now you can see over here 22, 17, 12, 7, 2. Pause for a while and try to guess what is the pattern. This is an easy pattern. You subtract, it's 2, 7, 2, 7. That means it's 5, half of 10, right? So it's 5. It's -5. You're subtracting by -5 over here throughout. Same way, over here you can see it's been added by 8 throughout. Now, this number which is being added is called the common difference, which is very, very important. And if the sequence is having the same common difference, a sequence can be any set of any group of numbers, but if it is having a set, if it's having a common difference, then that's called arithmetic sequence. And say this is an arithmetic sequence, this is an arithmetic sequence, and now each number, these are called term of a sequence. Okay, and this is the first term, which is important term, we will see in a while. And okay, this common difference is denoted generally by D, by the term D. Difference D. So that's the thing. Now you can see over here we have to determine whether it's a sequence, whether the sequence is arithmetic or not. So let's look into these numbers. Carefully see what is the difference between the first one. 17 to 14, that means 3 is subtracted. So it's -3 over here. Okay, all that together, sorry. It's -3 here. But now you can see next term it's -4, then again -3, -4. No, this is not helping us. Why? Because it must be the same common difference. Is it the same common difference throughout? No, it varies, right? It changes. -3, -4. In such case, we tell, no, this is not an arithmetic sequence. It does not have a common difference, therefore it is not an arithmetic sequence. Let's look into this problem here. Let's see what's the difference. You can pause the video and try it by yourselves. From 82 we are going to 73, so it's 9, it's -9. Then 73 to 64, again it's -9, -9. Now this over here is an arithmetic sequence. Why? Because there is a common difference of -9 throughout the terms. So yes, this is yes. Now here they have not asked us to find whether it's arithmetic sequence or not. That means it is an arithmetic sequence. They have told us to find the next few terms, next 3 terms. So how do we do that? Now from 11 to 7 you can see the difference is 4. It's -4. Again it's -4, -4. Now, I know the differences throughout the term is same. So if I subtract 4 from -1, I must get the next term. It's -5. Again, take out 4, you will get -9. And lastly, if you take out 4, you will get -13. So these are the three terms. The common difference is to be found out first. It is -4. And then you can easily add the common difference to the last term. If you keep on adding the common difference, so from -1 you add -4, again another, you will get -5. So add another -4 here, you will get -9, and again -4, you will get -13. So these are the answers. Here now, determine the next three terms in the sequence. I would highly encourage all of you to pause the video and solve this by yourselves. It's very straightforward. Try it everyone. You can see 31 to 18. If it's too huge number, if you're not able to do directly, use a calculator, it's fine. But now you can see here, it is 13. 18, 12 plus 1, it's 13 here. It's subtracted 13. Here as well, it will be -13. Or you can do any one of it, it's fine. And you can use the same one. And now, since you know it's -13 here, subtract -13. So 5, you need to add the common difference, but since it's -13, it will be subtraction, okay? Then over here, we will get -8. Now, whatever the answer you get, you need to add with the common difference. So it will become -21. And lastly, -21 plus of -13 will be -34. So these are the terms. These are the three terms. You can see -8, add 13, -13, and add -13. So it's -8, -21, and -34. So that's very simple and straightforward. But now we will see this important thing, the nth term of the arithmetic sequence. This is a formula. This is very important. Now, what if you have a sequence? You know something is going on a sequence and you need to find a far off term. Use this formula, you can get any term provided it is an arithmetic sequence. Only for arithmetic sequence, if you use this formula, you will easily get any term. Now you need to memorize this term. This is the nth term of the arithmetic sequence, an. So now if I have, say, 1, 3, 5, 7, 9, 11. Now the first term, the a1 is the first term, a1. This is a2, a3, and it keeps on going. Now I want to find an, that means the nth term. It can be any term. Now just for argument's sake over here, I will use seventh term. I need to find a7. What do I do? All I need to do is n will be 7, plug in the first value a1, that is 1, plus how many terms are there? What is n? Sorry, n is the seventh term I want, -1. What is this d? Common difference, it's 2, right? I'm adding 2 everywhere, so multiply this by 2. You can directly put this in calculator and get the answer, or we can solve it over here. 1, 7 minus 1 is 6. 6 times 2 is 12. So the answer must be 13. See, I've written 6, 1, 2, 3, 4, 5, 6. The next term would have been 13. So I'm directly getting it. But in this formula, if it's a huge one, say the 15th term, you can easily get it from this. Okay, so we will solve that now. And over here, n is the independent variable. It can be any value. It depends on the question or whichever term you want to find out. Then what about this an? An also is the dependent. It depends what's the nth value. The d is the slope, or it is the common difference. Okay, it must be a counting number n. We will see a problem. They have given us an arithmetic sequence, -4, -1, 2, 5, to complete the following. Write the equation first. First, you need to know the nth formula. an equals a1 plus n minus 1 times d. Now, what is this n? I'm sorry. What is the first term here? First term is this term, -4 plus. What is n? N is not given. Don't worry, just write it as n. You have to just write an equation, right? As n. minus 1. What is D here? You're adding 3. If you're getting confused over here because negative, just see easy numbers 2 and 5. What's the difference? 3 easily. It must correspond the same. Multiplied with 3. So here you will get minus 4 plus 3 times n is 3n minus 3. Now solve minus 3 and minus 7. You will get 3n minus 7. So this is the equation. The equation for the nth term is given as an. Don't forget the an. I have not written over here. So this is an equals 3n minus 7 for this particular sequence. It changes for different sequence. Now we have this particular sequence, and that's the answer. Now what else? They have not only told this equation, they have also told one more thing, that is to find the 16th term of the sequence. How do you find the 16th term? Now 16th term over here means a16, that's it. N is 16. Substitute over here. 3 times 16 minus 7. Or you can even use the same formula, the initial formula. Instead of n, you can put 16 and solve. You'll get the same answer. I'll show it in a while. Now here, 16 times 2 is 32, 48. 48 minus 7, that is equal to 41. This is the answer. Now what about this over here, the initial formula? Even here, I can just change this n to 16 and solve. It will be the same answer. 16 minus 1 will be 15. 15 times 3 is 45. And you have minus 4. So it is 41. Either way. So whichever, because we have simplified this, right? So we can use any of it. The answer would be 41 here. So all you need to do is in this instead of n, you put 16 and simplify. The answer is 41. I hope this is clear here. Now then, we will move to a real world problem. It's a person, Randy, has been training for a marathon, and it is important for her to keep a constant pace. She recorded her time each mile for several miles that she ran. First mile, her time was 10 minutes 30 seconds. Second mile, her time was 21 minutes. Third mile, 31 and 30 seconds. Fourth mile, 42 minutes. So what's happening? Each mile is being completed by her at 10 and a half minutes. So we need to first write the equation, the equation, the arithmetic function. So the formula is always an equals a1, the first term, plus n minus 1 d. The first, which is the first mile, how much time? She starts with 0. The first mile was 10.5. So this is A1. Whenever it's real world problem, just you need to apply where is 1, okay, and then consider that as A1. So here 10.5 is A1 because it's 10 minutes 30 seconds plus n minus 1, let it be. What is D? D is how much she moved. She was moving each mile in 10.5 only. So this is 10.5. We have to just simplify this. 10.5 plus 10.5 n minus 1, that will be minus 10.5. Now what happens? This and this cancels. You're remaining with 10.5 n. So an equals 10.5. So that is the first equation. An equals, or f of n, that's the function of n, it's the same thing, 10.5 n. Now they're asking how long will it take her to run a whole marathon? Round your answer to the nearest 1000 if necessary. Now here the marathon is how many? 26.2 miles. So basically you have to just multiply this n. Instead of n, you have to put 26.2. So here 10.5 times 26.2. You have to just multiply this. It'll be close to 200, and I'll just use a calculator because it'll be quicker. 26.5 26.2, I'm sorry, multiplied by 10.5. The answer is 200 and this is 26.2. So it's 275.1 minutes. So that would be the answer. But over here it's done by hours. So you just divide this by 60. That will give you the hours, 4.585. Why? Because it's not asked in minutes. And nearest, they are just asked for hours. So divided by 60. And nearest 1,000, that means there are three, sorry, there are three zeros over here in thousand, so there must be three decimal points after the three digits after the decimal point. So it is 4.585. That's the answer. So that is how you can easily solve these problems. So now let's go to another real world problem. Laniqua opened a savings account to save for a trip to Spain. With the cost of plane tickets, foods, hotel, and other expenses, she needs to save $1,600. She opened the account with $525. Every month she adds the same amount to her account using the money she earns at a after school job. From a bank statement, Laniqua can write the function that represents the balance of a savings account. Now see, she is saving 525 over here. They have told initially started with this, but every month, now zero she had initially so much, but the first month onwards she started adding 525 more. So it's going to be the same amount added to it. Okay, so you can see over here, one second. Now this is, sorry, she amongst the same. Okay, sorry, over here it is given. This is the balance which is being added. Every month she adds the same amount. So for 1 month, whatever is being added over here, the same amount is being added next time, next time, next time. That's what it means. So she started with 525. It's like the initial amount. Then how much is being added over here? You can see it is $55. So 55 must be added to the previous one. 55 plus 525, that will be 580. Now again 55 is added to this. When you add 55, it will be 635. It's given over here. So 635 in the second month. Then 690 in the third month, and so on. So when will she reach this amount? That is what we need to solve for. Now you can see over here, we need to first find the common difference because these values are given in the question, okay? And the common difference is 55 here. But we need to apply it in the formula, right? I'll just write the formula over here. An equals n minus, sorry, A1 is very important. A1 plus n minus 1 d. So we now know the d value. What is the n value? We don't know the n value. We know an, isn't it? Because here, what did they ask? How much she need to save? She needs to save 1,600. But I just realized they have not asked that. They have just asked you to write an equation. So, okay, that is fine. Whatever is the money, that's fine. D is important and A1 is important. Now, the most important thing over here, which is A1? You need to understand A1 is not 525 here. Why? Because this was the initial amount. In real world, this changes a little bit. Don't get confused. Whenever it's just numbers, you have to just solve some numbers. It's fine, you take these numbers directly. But here you must understand the month one, A1 would be 580. Okay, so you can see over here A1 is not 525 because you started initially over here. Now A1 would be the first month value, 580. That's the only thing you need to know. That's A1 is 580, and now you just substitute over here 580 plus n minus 1 times d. What is the d value? It's 55. You can simplify this equation. We will just see over here, it's already done. So all you need to do is simplify this, multiply 55 inside, it'll be 55n, and then it'll be minus 55, and you will have 55n plus 525. Don't get confused. Oh, this is the money. No, it's not like that. Now, this was the initial amount, and that's being 55 is being added all the time. So that's the thing. And now that is the equation, yes. But what about the next question? They have asked you to graph and determine its domain. So if you have to graph this, you can do in different ways. Now, basic linear function, we have already done a lot of graphing. Just take a x value. Over here it's n, so we take random n values. And now here, you can't take negative values because we know it starts from zero, initially the money, and then the first month, second month, third month, and so on. So just take from 0 to 5 months or something. You can see these are this is what she saves every month. After 6 months, she will have $855. Now you can just graph this. So initially she started with 525, next month it was 580, and so on. It will be a straight linear graph. Always arithmetic sequence will be linear. Do you know why it will be linear? Because it is having a common difference. The slope is always same, 55, right? When the slope is same throughout, it's going to be a linear function. That's it. So this is how you graph it. And the domain would be over here, all these values from 0. Though you can't take minus, it's from 0. And that's it. So it was a simple and short and easy lesson. I hope you have found it useful. It's about arithmetic sequences, any sequences with a common difference. When there is a difference which is equal or same throughout, say 2, 2, 2, or any sequences with a common difference is arithmetic sequence. And when you graph them, it will be a linear graph. So that's it for this lesson. If you have any doubts, please post them in the comments. I will try to get back to you as soon as possible. Take care, guys, and see you in the next video.